The problem statement from GATE Physics 2019 reads as follows. For the following circuit, the correct logic values for the entries x2 and y2 in the truth table are. We have been given a circuit here with some logic gates and some inputs, and we are given a truth table, and we need to find these two entries x2 and y2 which are required, and four options have been given. This is a multiple choice question, and we need to find the correct answer. Before we try to solve, let's just understand the difference between combinatorial circuits and sequential circuits. So on your screens in the green, you can see this portion can be referred to as the combinatorial circuit. Why is it so? Because we define combinatorial circuit as when the output values. So let's just label some nodes. Let's call this Q, this as R, this node as S, and finally this node as T. Now when you look at these, if you try to find the value of R or Q, or let's say S or T, the value of R will be nothing but A times G, right? Because this is simply an AND gate. Similarly, Q will be G times P. So whatever is the value of G and B, Q will reflect that. It will not depend whether G was high or low, let's say 10 clock cycles ago, 20 clock cycles ago. It will not depend. It will just see whatever the current value of G and B is, and the value of Q will be decided based on the ANDing of those two values. Similarly, the value of S, let's say here, the value of S will be simply C plus R, because this is an OR gate. So the two inputs are C and R. It will not depend, let's say, what the value of C was 10 clock cycles or 5 clock cycles ago. So hence these are called combinatorial circuits. On the other hand, if you see this portion of the circuit, which is in the blue rectangle, this is a sequential circuit. Why? If you try to find the value of X, it is a NOR of S and Y. So whatever the value of Y in the previous clock cycle was, and whatever the current value of S is, that will be XORed and stored in the value of X. So what's happening is that the current value of X is depending not only on the present value of some inputs S, but some previous value of some input Y. So hence these are called sequential circuits, and I'll write this point that sequential circuits are those output depends on previous and present inputs, while combinatorial are those in which output depends on the present values. So what do we mean the previous and present input values? We'll see when we solve this question. So this was the truth table that was given to us. So first row has been entirely populated. This was given to us. So let's say this is at clock 1, let's say this truth table, and we need to find out what's happening in clock 2. So one more thing, all the sequential circuits, they have at least one clock running. So clock is usually a square pulse like this. So this is the clock. When I mean clock 1, let's say here, this edge. Clock 2 is this, clock 3 is this. So I'm writing it clock 1, clock 2, clock 3. So we have been given that at clock 1, this means at this edge, these are the values. And we need to find the value of X and Y, right? We need to find these two values at clock 2. So we need to find the value X and Y at this clock edge. So as always, we'll just try to find out, because in order to find X and Y, we need to find S, T, R, Q, and A, G, B are given. So we'll try to solve this circuit for the clock 2, that what happens at this clock edge. So A is 0 at that point. A is 0, G is 0, B is 0, P is 1, and C is also 0. So let's try to find what's the value of R. So R would be 0 times 0, because this is 0, this is 0. 0 times 0 is 0. When we try to find out Q Q will be again 0 times 0. This is an AND gate, so Q will also be 0. Let's try and find the value of S. So S will be 0 plus 0. This is an OR gate. 0 plus 0 is 0. Similarly, if we try to find the value of T, T is 0 plus 1. So T will be equal to 1. Right. And if you need to find X2, we need to know the value of Y. So the value of Y will be nothing but Y1. That is the value of Y in the previous clock cycle. This means at this edge. So value of Y1 was 1. So Y1 equal to 1. Similarly, in order to find the value of Y2 here, right, in order to find the value of Y2, we need to find the value of X1. This means whatever the value of X in previous clock edge here. So that is given to us as 0. X1 is given equal to 0. So X2 will come out to be, this is a NOR, this is a NOR gate. So it will be 0 plus 1 whole bar. So it will be 0 plus 1 whole bar, which is 1 bar. So X2 will come out to be, so I am solving X2 here. X2 will be S plus Y1 whole bar. The value of S is 0. Y1 is 1, so that will be 1 bar. This will be 0. Similarly, if I try to solve Y2, this will be T XOR X1, right? So what's the value of T? T is 1, X1 is 0, 1 bar, 0. So we have obtained that X1 and X2 both will be 0. So we had obtained that. Now we now know that this is equal to 0 and this is also equal to 0. Now just to again iterate that how do these sequential circuits work, I'll again now try to find the row 3, that is at clock 3. What is happening? This is clock 3. This is clock 3. This was clock 2. This edge, right? So at clock 3, we know G is 1, A is 0, B is 0, P is 0, C is 1, and as all again I'll label them as Q, R, S and T, and we need to find X3 and Y3. And so the previous value here, the previous value of this node would be X2, because know that this is the output coming from here to this. Similarly, the value of this node would be Y2, that is the value of Y in the previous cycle at this clock edge, right? So let's try to find the value of R. R will be 0 into 1, which will be 0. Q would be 1 into 0, again 0. T would be P or Q, so 0 or 0 is again 0. S would be 0 plus 1, so that would be 1. And we know Y2 is equal to 0, we obtained in the previous slide. X2 was also 0, right? So now I can write X3. X3 would be S NOR Y2, so we denote it like this. So the value of S is 1 plus 0 whole bar, that's 1 bar, that should be 0. X3 should come out to be 0. Similarly, Y3 would be T XOR X2. So the value of T is 0, we obtained it here. And the value of X2, that's also 0. So 0 plus 0 whole bar, that's 0 bar, and that's 1. So we obtained X3 should be 0 and Y3 should be 1, which is the case here. So this again demonstrates the values of X2 and Y2 that we determined 0 and 0 were indeed correct. Right, so we solved, this was the problem, the sequential circuit, and we obtained that X2 and Y2 were 0 and 0, which is the option B. So this is the correct option. Thank you for listening.